Guys, welcome to this video on the fundamental theorem of calculus. So we've been looking at area under a curve and also antiderivatives. Now we're going to take this the next step further and look at how we can expand on it to make it the fundamental theorem of calculus. So what we've got here is the integral between points A and B of some function f of x with respect to x, which is what the dx stands for. What this actually means is the antiderivative of the function f of x at point A, when x is equal to A, minus the antiderivative again when x is equal to b. And that's really what it comes down to, that this bit here is just going to be equal to this bit here. We'll go through an example in a moment, but first what I want to go through are some of the properties of these, what we call definite integrals. Now, they're definite integrals because they have a definite area, or two definite points in which we're going to look at the integral over. So let's look at some of the properties of definite integrals. And I do want you guys to get these written down, so as I'm writing down, you can either be copying them down yourselves or paying attention, pause the video after and copy them down. So, the first one. So, definite integral from a to a, that's just going to equal 0. And if you think about it, it's just really like saying a number take itself, it's just going to be equal to 0. So that's the first one. The second one, so if we've got the definite integral from b to a of f of x with respect to x, it's just the same as minus the integral from a to b. So just flipping a and b around, and we expect that would change these two around. It's like going, basically chucking it out the front, going f of b, take a, and swapping it around. So if we've got the definite integral from a to b of f of x plus the integral from b to c of f of x, bearing in mind f of x, so these functions here have to be the same. Then we've got from the integral from a to c of f of x. Alright, another one, and I'm going to run out of room in a minute, so if you're not copying them down, I'll tell you when to copy them down before I clear the screen and start a new page. So if you're looking at the integral from a to b and we've got k with respect to x. Well, k is just a constant, so it's k times b minus a. If you think about that for a moment, k would represent our value on the y-axis, and a to b is a distance on the x-axis, so really it's k times, or x times y, which, if you think about it, it's just the area of a square. Alright, another one. So again, if k is a constant, we can actually take it out, much like we do the same without really thinking about it when we're deriving something. We're just taking the constant out. Alright, can you make sure that you get these written down? I'm going to clear the screen. So there are 5 there I want you to get down. We've got 1 more to go through, so pause the video, get these ones written down, and I'll see you in a moment. Alright, so hopefully you've got those written down, and if you haven't, rewind the video and then get those written down. The final one that we're going to go through is alright, so if we've got a function, one function plus another plus or minus another function with respect to x, then we can actually split them out into 2 different integrals. So we've got one function here, another function here, and we're splitting them out into 1 and 2. So if we go 1, 2, that's 1 and 2. So we can split them out like that. Alright, let's have a quick look at an example, and then we will leave it there. So, using the fundamental theorem of calculus, find the area between the x-axis, so we're going between the x-axis and y equals x squared. So, and we're doing this between x equals 0 and x equals 1. So, when we see a question like this is how we're going to write it out. We're going to do the integral between 0 and 1 of x squared with respect to x. Alright, so the first thing we have to do when looking at a question like this is solve for the antiderivative. So the antiderivative of x squared is, so let's go f of x is just going to be equal to x squared plus 1 over the power, it is plus 1. So that is just going to be equal to x to the power of 3 over 3. Alright, so now that we've got that, what we'll do is, when x is equal to 1, so 1 to the power of 3 over 3, take 0 to the power of 3 over 3. And that will give us 1/3 units squared. And that's really all it is. So using what we spoke about before, where we've got f to the, so breaking this down, it becomes f of 1 take f of 0. So that then becomes this part here, and we get our final answer. So hopefully it's made a bit of sense for this video on the fundamental theorem of calculus. We'll go through some more stuff in class. If you've got any questions, just ask. hopefully you found this video to be of some help. If you've got any questions, again, just ask. Any clarifications, we'll talk about through in class. So, as always, thanks for watching, and we'll see you next time.